big N, open bracket, mu sub M minus mu sub W, and uh, open sigma sub M squared over N sub M close plus open sigma sub W squared over N sub W close bracket. If sigma sub M squared and sigma sub W squared are known, then this approximate normal distribution can be used to compute p-values for the test of the null hypothesis that mu sub M minus mu sub W equals D sub naught. In practice, however, these population variances are typically unknown, so they must be estimated. As before, they can be estimated using the sample variances S sub M squared and S sub W squared, where S sub M squared is defined as in equation 3.7, except that the statistic is computed only for the men in the sample, and S sub W squared is defined similarly for women. Thus, the standard error of big Y bar, I'm starting this line. Thus, the standard error of big Y bar sub M minus big Y bar sub W is the standard error of big Y bar sub M minus big Y bar sub W equals the square root of S sub M squared over N sub M plus S sub W squared over N sub W. Equation 3.19. Redoing the square root of S sub M squared over N sub M plus S sub W squared over N sub W, equation 3.19. For a simplified version of equation 3.19, when big Y is a Bernoulli random variable, see exercise 3.15. The t-statistic for testing the null hypothesis is constructed analogously to the t-statistic for testing a hypothesis about a single population mean by subtracting the null hypothesis value of mu sub M minus mu sub W from the estimator big Y bar sub M minus big Y bar sub W and dividing the result by the standard error of big Y bar sub M minus big Y bar sub W. T equals open big Y bar sub M minus big Y bar sub W close minus D sub naught over the standard error of big Y bar sub M minus big Y bar sub W. T statistic for comparing two means, equation 3.20. If both N sub M and N sub W are large, then this T statistic has a standard normal distribution when the null hypothesis is true. Because the t-statistic in equation 3.20 has a standard normal distribution under the null hypothesis when n sub m and n sub w are large, the p-value of the two-sided test is computed exactly as it was in the case of a single population. That is, the p-value is computed using equation 3.14. To conduct a test with a pre-specified significance level, simply calculate the t-statistic in equation 3.20 and compare it to the appropriate critical value. For example, the null hypothesis is rejected at the 5% significance level if the absolute value of the t-statistic exceeds 1.96. If the alternative is one-sided rather than two-sided, that is, if the alternative is that mu sub M minus mu sub W is greater than D sub naught,